Hey, in this video, we're going to answer what Solana is. I'll tell you about the fundamentals of Solana, why it's so special, and we'll also touch on the idea of proof of history, too. Let's go. What is Solana, exactly? Solana is a cryptocurrency project that's very similar to Ethereum, the second largest crypto platform in the world. Same as Ethereum, Solana aims to provide its users with the tools and environment to create decentralized applications, smart contracts, and other awesome projects, and all these are the biggest differences comparing those two to Bitcoin. ETH is extremely popular and is the old standard on which smart contracts and other decentralized platforms are built. In comes Solana, offering extremely fast transaction speeds, and advanced scalability features that are also planned for Ethereum in upcoming years. Which one you'll choose? Should people switch from ETH to Solana? Maybe these two blockchains should be used in conjunction with one another. Well, in order to answer these, and similar, questions, you should first be aware of what exactly makes Solana so special. As I've mentioned earlier, Solana aims to improve on all of the core aspects of Ethereum. These include things such as transaction speeds, smart contract creation, fees, use of its consensus algorithm, and general usability. Let's cover each of these, in a simple to understand manner. Imagine that you're planning to send some money to your friend in another country. Perhaps you owe them money, or are buying a new iPhone. You have two methods, or two payment gateways, of sending the money. Let's call them Method A and Method B. With Method A, you will send the money, and will have to wait a few hours for it to arrive to your friend. If you send the money with Method B, though, as soon as you press the send button, your friend will receive the money, it's instant. This is rather similar to how transactions on Ethereum and Solana work. Ethereum can handle up to around 40 transactions per second. Sounds pretty decent, right? Well, until you find out that Solana can handle up to almost 70,000 transactions per second. And this is the future of Ethereum too. The difference isn't anything to scoff at. Transaction speeds on Solana are astonishing, and you don't even need to compare it to today's Ethereum. And to compare and understand these metrics globally, take traditional banking, as an example. Visa can theoretically handle up to 24,000 transactions per second. 70K on blockchain, versus 24K today in real life. Do you feel the difference and why blockchain tech is booming so much? Now, let's stick to that same example. Are you sending money to your friend? Let's say, you want to send $10. If you send it with slow method A, not only will you have to wait longer for the money to arrive to your friend, but you will also have to pay, say, $4, as a transaction fee. Sending the same $10 via method B, the transaction fee will be just a few cents. So you pay more for the slowest service. How fun is that? And does it make any sense? This is another huge point that comes up when talking about Solana. The network allows users to make transactions for a fraction of the cost that you would pay on Ethereum. Smart contracts were an invention of Ethereum. ETH was the first blockchain that came up with the concept, and the developers behind the network in question have taken the concept very far. Now, when it comes to smart contracts, I have a dedicated video about it on my channel. Check it out, if you want to understand the topic in depth. Solana, however, does also support smart contract development. On Solana, smart contract development is much faster and simpler than on ETH. This is due to a variety of reasons, actually. Solana uses a different programming software than Ethereum, is simpler to get into, and requires less time to truly be grasped by developers. Now, whenever you're researching Solana, the term proof of history is bound to come up, all the time. In the world of crypto, there's a concept called consensus algorithm, or consensus mechanism. Essentially, what this refers to is the way how the communities behind different blockchains make decisions, and come to agreements on serious questions and issues. The most popular consensus algorithms are proof of work and proof of stake. These are large topics, and when you're watching this, I likely do have videos about them on my channel. Make sure to check them out, if you're not familiar with the concepts. At first glance, you might think that Solana uses a different consensus algorithm, Proof of history. Let me tell you right off the bat, that's not the case. Proof of history is actually just an improved version of proof of stake, the mechanism that will be adopted by Ethereum 2.0 probably in upcoming years. In addition to all of the staking functionality that you have with proof of stake, proof of history also implements universal timestamps for transaction confirmations. Traditionally, when different validators on the network confirm transactions, they send that information relying on their own local clock timestamp without knowledge of any other participant's actual clocks in the same network. In other words, if you're based in New York, and your friend is located in London, even if you confirm the transaction at the same time, the timestamps will be very different. The lack of a standardized clock, or, let's say, a universally trusted time source, meant that when a transaction proceeded, there was no guarantee that every other active party in the network would stay synchronized with the same timestamp you set. And this is a huge bump for network speed, because it takes time to figure out what happens, and time is everything on a blockchain. Normally, most smart blockchains, like Ethereum, rely purely on external mechanisms to add their timestamp, which they then apply to confirm all transactions in the order they were received. So, as we see, network synchronization is the key feature of Solana. Proof of history sorts this out by arranging all transaction confirmations in an organized, set chronological order. Allow me to give you an example. Imagine that you're working from home, and have decided to order a few things. You order groceries from the store, some lunch from the local restaurant, and a book from a bookstore in another town. You did all of the ordering in that manner. However, your lunch came in first, since the restaurant was half empty. The book came in second, since they noticed that there's a copy in a store near you. And lastly, you received your groceries, since there was a traffic jam in that part of town. Now, while all of these processes happened in a very random order, you have your app, where you can check exactly when you've asked for each order to be sent out, and when they were sent out by the respective establishments. No matter when they came in, you know the time they were sent to you. Now, do keep in mind that I've discussed a very simplified and broad version of proof of history. The concept is much more difficult than that, and there are other aspects that need to be kept in mind. I hope you found it interesting. Thanks for watching, and I hope to see you in our next video.